Good morning, everyone. We're going to talk about the law of cosines. So this is section 8.5. So first things first, we have that we are looking at the law of cosines. So this is another one of our trig formulas that we're going to be looking at. And our EQ for today is, when do you know how to use the law of sines versus the law of cosines? Well, let's go ahead and address that right now. The two kinds of triangles that we ended up looking at were when we were given two angles. That's when we could use the law of sines. So if we have two angles in a side, then most of the time we're going to be able to use law of sines. So that's where we have a side that's sandwiched between two angles, or we happen to have two consecutive angles and a side. Okay, so that'd be something like where we are given angle B, angle A, and then side B. That would be something that would be very similar to an angle side. Law of cosines is going to be different though. Law of cosines is when we have all three of our sides being given to us. That's A, B, and C, all the lowercase letters. Okay? Or it might be that we have an angle that is sandwiched in between two sides. So we have a sassy triangle, an SAS. So that would be like side, angle, side that we would be given. Okay? So that's one easy way to understand which one we're going to be using based on the formula, and you'll see why we need those things in the formula momentarily. But what if we don't have a picture? If we don't have a picture, it's still not too bad. If you don't have a picture, you'll know it's going to be side, 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 because each one of your sides is always a lowercase letter. So you're going to be given these three pieces of information. You'll see that they're all lowercase letters. You know that it's going to be side, angle, side if you have a big letter, a capital letter, and then the other two letters are going to be your lowercase letters. And notice that all three of the letters in this case are different. So in this case, we actually don't have any corresponding sides and angles whenever we are going to be looking at using the law of cosines. That was a big, big deal if we had law of sines. We needed a corresponding side and angle pair. We don't need that for law of cosines. So how does law of cosines work? Let's go and find out. So here's our formula for law of cosines. It's a squared equals b squared plus c squared. And what we want to look at here is that there's a couple of key things that should look familiar before I even go any further. The first thing is a squared equals b squared plus c squared. That seems familiar, right? That's a lot like the Pythagorean theorem. But we know this shouldn't work for the Pythagorean theorem because this is not a right triangle. And we know that the Pythagorean theorem is only for right triangles. Okay, so it's got this other part to it. It's got this negative 2bc times the cosine of a. And that starts to look like a really gross formula. But here's what we want to pay attention to. There's a couple of key things that are given to us at the beginning and end that are going to make it a lot easier to utilize and remember this formula. It's lowercase a and capital A. So that means I have corresponding side and angle pair on the outside of the formula. And the rest I can just kind of fill in inside the sandwich, okay? So we can then think about anything else or any other corresponding side and angle pair I can utilize too. So it doesn't matter which letters I'm given, I can rewrite this for any corresponding side and angle pair that I want. So for example, let's say that I want to try and find side B. I start off with b squared, and then I fill in its corresponding cosine of its angle, and then I go into my Pythagorean theorem part with my remaining two sides. That's a squared and c squared. And then 2 times the remaining two sides, so that's negative 2ac. Okay? I can do the same thing if I want to actually end up finding the side c. Okay? So I start off with the side that I want to find, c squared, and I look at the end of the formula, the cosine of its corresponding angle, and then I say, okay, well, let's go ahead and fill in the Pythagorean theorem part. The other two sides that I don't have so far are a and b, okay? And then we can end up looking at the negative 2 times those remaining sides, negative 2 times a times b times the cosine of c. So once you kind of get comfortable with that, it's actually not too bad to kind of restructure this formula. Okay, it should be presented to you still, like you can have it on a note card for a final exam or for a test. That's not that big a deal, but it is something that you can try and create all on your own. So work with that. Now let's go ahead and take a look at an example. So for this first example we have, it shows that I want to solve for angle C. I know it's an angle because it's a capital letter. right? So I want to try and think about what does this triangle look like. I've got a sketch of a triangle over here. It does not have to be to scale, at least a little bit, but we could go ahead and take a look at what we have here and we could start labeling things. So I have side A is equal to 8, side B is equal to 19, and side C is going to be equal to 14. Okay, it might be helpful for you to label the given angle that corresponds with that side that we are looking for. Okay, this is the thing that I want to try and find. So that means if I'm looking for angle C, we think, wait, I didn't have anything where angle C was all by itself. That's okay. We can still set it up the same way that we did. So we think about, I'm looking for C. I start off with the side C squared, and then I have cosine of that given angle. Then I fill in my Pythagorean theorem part with the remaining two sides, a squared and b squared, and then I subtract from it 2 times those remaining two sides, negative 2ab times the cosine of c. Now let's go ahead and plug in the given information that we have. Okay, so first of all, for c, we can plug in 14. For a, we can plug in 8. For b, we can plug in 19. Do the same thing for the negative 2ab, negative 2 times 8 times 19. And then we have cosine of our unknown angle, and that's the thing that we want. So this actually is almost all calculator work and just the tiniest little bit of algebra that we need to work with. So let's go ahead and utilize our calculator at this point and evaluate all of our given numbers here. So I'm going to go over to my calculator and punch in some numbers. So first thing to punch in is that 14 squared for the left side of the equal sign, and that's going to be 196. Then we've got the a squared and the b squared, so that was 8 squared plus 19 squared, and that was 425. And then we're going to do the negative 2 times the a times the b. So I have negative 2 times 8 times 19. I want to do all of these separately, and we'll see why in just a moment. And that's going to give me negative 304. So let's go back to our page, write down what we have. So at this point, I have on the left side 196, and that's going to equal 425 minus 304 cosine of c. So here's why I had to do the right side separately. 425 and negative 304, we can't subtract those two. We can't combine them because they're not like terms. Negative 304 is attached to this cosine of c. So what we need to do now is try and solve, do a little bit of algebra to try and solve for cosine of c. So the first thing I see that I can do is I can subtract 425 from both sides. Might need my calculator to help me out with this. Those are going to cancel out. I go back to my calculator, and we have 196 minus 425. It's going to give me negative 229. So now I have negative 229 is going to equal negative 304 cosine of angle C. And here's what we want to remember at this point. Negative 304 is being multiplied with cosine of C. How do we undo that multiplication? We divide. So divide by negative 304. Those are going to cancel out. And over here on the left-hand side is a really gross fraction. I'm not going to try and reduce it. I'm actually just going to leave it as it is and write it out exactly as I have it here so far. Negative 229 divided by negative 304, and that is going to equal the cosine of angle C. And we think, well, hey, how do I get rid of the cosine? That's just still angle C. So what we need to remember is that, hey, I can use inverse trig. I can use cosine to the negative 1 to undo cosine, leave me with just C. But whatever I do to the left-hand side, I have to do to the right-hand, to the other side as well. So I take cosine inverse of that gross fraction. And here's why we left it the way it is, because otherwise I'd have some rounding error and it wouldn't be quite as precise. So now I can use this on the left-hand side, and that is going to just give me my angle C. Let's go back to our calculator and punch that in. So I go to my trig button, that's just to the left of the 7. Cosine inverse is right over here, and we are punching in negative 229 divided by negative 304, all still in the parentheses, then we can close it out, and we get 41.1, and that is an angle measurement. So there we can go back and write out what our angle is to the nearest tenth of a degree. 41.1 degrees equals angle C, and that's it. Okay, so law of cosines, it's mostly calculator work. Don't be intimidated by a lot of it. It's very simple algebra. You just have to remember how to undo the cosine ultimately at the end and how to set it up in the beginning, and that's really it. Let's take a look at another example. All right, so for this one, take a look at what it is that we are actually trying to solve for. It says we are solving for a side, lowercase a. That's what we want to know. When we look at what is it that we are given, and I want to verify first that I can indeed use the law of cosines for this. I'm given an angle and then two different sides, so that is going to be an SAS triangle because the angle A is sandwiched in between these two sides B and C. And you say, well, how do you know that without the picture? If I go back and look at the very beginning of my notes, this is exactly what an SAS triangle is that we thought would look like. So I don't even need to draw a picture. If you want to, you can, go ahead, but hey, I'm all about less work. If we don't have to do as much, let's go ahead and work with that. So first of all, figure out what is it that we actually want to solve for, A. So A squared is going to go on the outside of my law of cosines formula, and then I'm going to have cosine of angle A at the end. Fill in my Pythagorean theorem part with the remaining two sides, b squared plus c squared, and then I have negative 2 times those remaining two sides, negative 2bc times the cosine of a. We can start plugging things in. Lowercase a is the thing that I don't know. B squared, I know that's 15. C squared, I know that that is 10. Negative 2 times 15 times 10, and then we have cosine of 115 degrees. So now that I have this, I want to take a look at the right-hand side real quick and just kind of pay attention to what I have here. 15 squared plus 10 squared minus 2 times 15 times cosine of 115. That's all numbers. That means that entire thing can be plugged into the calculator, and it can be plugged in all in one step. This is super easy. Whenever we're trying to find a side, it's really, really light work. So let's go ahead and do that. Punch this into our calculator. We're going to type in 15 squared plus 10 squared minus 2 times 15 times 10. Hit my trig button to get cosine. We're not doing inverse cosine this time because we have the angle that we need, 115. This is the entire right side of that equation. Go ahead and hit enter and we get 451.785. And I actually want to leave as many decimals as I can at this point just to alleviate any roundy error. So a squared is going to equal 451.785. And we think, well, wait, okay, I should be done, right? No, we have to get rid of this squared. How do we get rid of squares? Take the square root. If I take the square root, I'm going to have just a on the left-hand side, and now I can take the square root of that answer that I had on my calculator. So we take the square root, we have to press Control and then the x squared button of 451.785, and there we get our result, 21.2552. 21.25 should round up to 21.3 for giving us that first decimal place, and A is going to equal 21.3. That's it. So, you guys, really, this is it for law of cosines. There's another example that you can take a look at, or I can help you out with as you finish up your problem, but I encourage you to try and do it on your own. Once you're finished, show it to me, make sure we understand and we've got any questions answered, and then get started on your assignment.